Hi, this is lesson 411, Introduction to Factoring Expressions. And so in this lesson, this is, like it says, it's really an introduction. Um, we won't be factoring in this lesson, but we will learn a little bit about how we can factor and what is factoring. And so I'm starting off with just kind of telling you what you should know at this point and and what we've kind of done in previous chapters was you should already be familiar with the area model, and we have done this in some of our homework problems, and it's kind of has come up on some of the lessons as well. All right, so how to multiply an expression that looks like this by using the area model is something we've done, and just kind of a reminder of what that might look like. I have an area model for us, and what we've been doing, and if it hasn't been clear before, is we've been taking these expressions which have been um, written as a product, two things being multiplied together, and we're writing them as a sum. All right, so when we multiply two things, the answer is considered a product. So this is considered our product, and we've turned it into a sum. All right, so and where are these numbers coming from? Well, x plus 5 and x plus 8 are two expressions that we're multiplying. You'll notice in our area model, these are the expressions on the outside of our area model, right? So x plus 5, we have x plus 5, and then x plus 8, x plus 8. Right? So those terms go on the outside, and when we multiply, I'll zoom into that for a second. When we multiply the numbers or terms on the outside, for example, x times x gives us x squared. We have 8 times x gives us 8x. X times 5 gives us plus 5x. And then the last one, a positive 8 and a positive 5, when we multiply those, we get a positive 40. All right, plus 40. All right, so everything inside is being generated by the numbers that we're multiplying on the outside. And so if we use those numbers, and if we look closely at those numbers, you should see that within the area model, there are a couple of terms that are the same, right, or like terms. So we have a 5x and we have an 8x. Those are actually two terms that we could combine together. So when we write it as a sum, we have x squared, which is our x squared, and then we have a 13x. 13x was the two x's combined, and then the remaining term was a positive 40. All right, so all we're doing is adding up everything inside the box, and the terms on the outside were our product. The terms inside would be our sum. All right, so area as a product is the same thing as area as a sum. So in the end, all we're talking about is area. Area is the space inside. So if we want to find the area, we have a couple of options. We could either add up all the areas inside, which is our sum, or we can multiply the base and height of this rectangle, and that would also give us our area. So this is area as a product and area as a sum. Right? These two equal each other. They're just written in a different form. All right, so when you write the sum as a product, this is what we call factoring. All right, so like I said, this is introduction to factoring. So one of the key parts to this is really understanding what that word means, factoring. So one or a couple of terms you should be familiar with when we talk about factoring is what is factored form. So oftentimes maybe a problem might ask you to write an expression in factored form. So you might say, well, what's that? What does that look like? Well, it's an expression written as a product. All right, so again, product really just means multiplication, right? The answer to a multiplication problem. So we're looking for something times something else, two things. That's factored form. And then factor is another term you need to know. And factor represents the expression being multiplied. So in this case, here's an example below. So factored form, an expression written as a product, you'll notice we have two expressions being multiplied, right? So keep in mind we're no longer using like an x to represent multiplication since we're using variables as in our expression. So x, we don't want to confuse it with the multiplication. So you could either just use parentheses, which means multiplication when they're stuck together. Or if you really wanted, you could put a little dot in between. That would mean multiplication as well. But for the most part, this is considered factored form. And each individual expression we would call a factor, right? Each one. So this would be the same thing even if I had 5 times 3. This would also be factored form. And then each one of these would be considered a factor, right? It doesn't matter if it's a number or if it's a number and a letter or just one of each. I could use different letters, 6y times, let's see, 4y minus 3, right? So this is, you'll notice, again, they're being multiplied. Each one is considered a factor. All right, so everything in the parentheses is considered a factor. All right, so that's some terminology you need to be familiar with. And so moving forward, let's look closer at the area model that we have been using to see if we can understand how we could use it to factor. So here's 3 problems that we're going to be going over. Now in these 3 area models, you'll notice everything inside has been given to us. So this should make it a little bit easier to find the area as a sum because everything inside comes, or the sum comes from everything inside the area model. So we're going to do 2 things. We're going to write the sum, and we're also going to write the product. So area as a sum and area as a product based on the information that's given to us. Now, in order for us to write the product, we will need to figure out the terms that go on the outside. So that's what we're trying to practice in this type of problem. So I'm going to move this a little bit up so I have some room to write. And actually I might zoom in. To a couple of these. All right. So the first thing that I could probably do is I might even just go straight to write the sum. And I'll label it so we could tell them apart. So the sum comes from the inside. So everything inside was considered our sum. So like I mentioned before, we have a couple of terms that are like terms, so we could add those. That's perfect. If they're not like terms, then we can't add them. So for the most part, what we're going to do is really just copy everything inside. So I'm going to do 6x squared plus, well, what's 15x and a 2x? That's going to give us 17x. And then the last term is a 5. So there's no more terms that are alike, so we're going to stop there. All right, now to do the product's going to be a little bit more work. So let me get that ready for us. All right, so I need the numbers on the outside. And so what numbers would possibly go in this spot or this spot or this spot? Sometimes I recommend just kind of looking at it. Maybe it's easy to tell, maybe it's not. So let me kind of give you a trick to this to make it a little bit easier. And that is, if you are familiar with the, I guess, what's the term? Common factor. Sometimes we might say, what's a common factor? What number goes into both of these numbers, right? And we're looking for the greatest common factor. So we're looking for the greatest common factor. Greatest common factor. So when I look at, let's say, these two, and I say, what number goes into both 6x squared and 2x? What's the biggest number? Well, 6 goes into 6, but 6 does not go into 2. So that's not going to work. But I notice 2 does go into 2 and 2 goes into 6. So then I could say, well, I think a 2 goes on the outside. And you should notice that they both have an x. So this one has one x, and this one actually has two of them. There's actually like two x's here. So they do have an x in common. So I'm going to put an x outside here. And then I could look at maybe the second column and say, what do they have in common? What number might go into both of those? And so if you notice, a 5 goes into 5 and 5 goes into 15. So that's a number they have in common. Do I need to put an x here? Well, there's an x here, but you'll notice there's no x with a 5x. So they don't have a 5 in common. I mean, they don't have an x in common. So they only have a 2x and a 5 for those two columns. So you would do the same thing going with the rows and kind of seeing what they have in common. That's one approach. Or you could think about, what can I multiply to 2x to give me 6x squared? Since I know multiplication is being used to get the inside. If you can't think of it, then just go ahead with the greatest common factor and think about what number goes into 6 and 15. 6 and 15. Well, 6 doesn't go into 15, but I believe 3 does. And you should notice that there's an x squared and there's an x. So at most, they're going to have an x in common. And if we test that out, think about it, 2x times 3x, that should give us 6x squared. All right, so all we need is one more term. What do they have in common? 2x and 5. They don't really have anything in common, so the only thing would be a 1. All right, see if this makes sense. So 5 times 1, you always have to test it out. 5 times 1, does it give us 5? And that works, so that's perfect. 2x times 1, that gives us 2x. So that works as well. That's awesome. All right, so now that we have the numbers on the outside, what we're going to do is just copy them. So the first factor is 3x plus 1, and the second factor is 2x plus 5. If you happen to switch the order there, that would be okay as well. If you say, well, I think I like it like this better, 2x plus 5, 3x plus 1, that's okay. Some people like it like that because it looks like base times height, which is perfect. So base times height. I think I'll leave it like that. But if you happen to switch the order, that's okay as well. Let's see. We have a couple more of these to do. And so we'll kind of repeat the same process. Let me zoom into that. We're looking to write the sum. And so let's see. If we look at all the terms inside, I don't see any like terms. We have a 5xy. There's nothing else with an xy in it. This has a y. There's nothing else that has just one y in it. So it looks like all these are kind of unique terms. So all we're going to do is just copy them as they are. So 5xy plus 15x minus 2y minus 6. All right, that's it. So that was easy. We just had to copy it. And then the next step is looking for greatest common factors. So let's start with the row this time. We have 5x, y, and we have 15x. Well, I noticed the 5 right away, and they also have an x. That's perfect. So they have a 5x in common. And then at the top, I see a 2 and a 6. Right away, I realize that 2 goes into both of those. But not just any 2. I noticed they both have a negative 2. And so to figure out the bottom terms, I'm going to kind of work backwards with multiplication. What number can I multiply to negative 2 to give me negative 2y? Well, the only thing missing there is a y. So that should work on the bottom too. So 5x times y gives us 5xy. That's perfect. And then so one left. Let's see. If you're not sure, if you look at these two terms and you're like, I can't think of which number goes into both, then I would say look at the outside and say, what number can you multiply to negative 2 to give you a negative 6? And so hopefully it kind of sticks out there. This would be a positive 3. Right? You could also test it out with the bottom two. 5x and a positive 3 turn into a 15x. All right, so this takes some time. You have to think about what you can multiply. And so you kind of will keep asking yourself probably the same questions over and over. All right, so this is going to be the product on this one is going to be, we'll do base times height, y plus 3 times 5x minus 2. You'll notice I put 5x first and then the minus 2. You always want to put the letters first if you can. You don't want to write it as minus 2 plus 5x. So even though that's technically, like it works mathematically, the factored form does kind of expect you to put the letters first. Okay. So, and then the last one, let's see if I could squeeze this in. This is kind of similar to the first one. The second one's a little bit different because it had x's and y's. So this last one definitely just has x's. We're going to write out the sum on this one. This is going to be 12x squared. But here we have, I notice I have a positive 16x and a negative 9x. So be careful here. If you can't do it in your head, definitely just use a calculator, make it easier. We are looking at 16 minus 9, right? 16 minus 9. So if you're not sure what that is, definitely type that into the calculator. All right, or if you happen to type in, if for some reason you happen to type in minus 9 plus 16, it would still give you the correct answer. All right, so and don't forget the x on that one as well. So this is going to be plus 7x, and then there's a minus 12 at the end, which is going to be this term. All right, and so the hard work is the product. So as we write our product, we're going to need to figure out the bottom terms or the terms on the outside. So 9x and a 12x squared. The term that probably goes into both of those is going to be a 3 and an x. And the second column, 12 and 16. What number goes into 12 and 16? That's going to be a 4, I believe. So that's going to be a plus 4. You'll notice again, there's no x on this. Even though the 16 has an x, the 12 does not. So I could only take out a 4. And then doing the same thing across 12 and 16. Well, we just kind of did that with the 4. So I'm going to put a 4x because they both have x's. And then the top one, we're going to have a negative 3. If you're not sure if that was supposed to be a positive 3 or negative 3, you could always test it out. What positive 4 times what will give me a negative 12? So definitely, if one's positive, the other one had to be negative. All right, so let's write that out. So this is going to be, I'll put 3x plus 4 times 4x minus 3. All right, so here's kind of us writing out our sums and products. Definitely you need to be comfortable with your area model. We've seen this in our homework a number of times, so definitely practice those. So one last thing to kind of point out, a little bonus on this type of problem is the way the problem set up is there's students working on this in class. One student realizes there's a pattern with the diagonals. And so the student highlights the diagonals, but then has to leave the class. And so the question is, what did this student notice that maybe we didn't notice before? All right, what is the pattern with the diagonals? And if there is one, does it work for all 2x2 area models? All right, so I'll let you see if you can answer that question. Or see if you notice the pattern. And so in case you're not sure what diagonals are, we're talking about these. So these would be our diagonals. So we have, for some reason, 6x squared and plus 5 were highlighted. And 2x and 15x were highlighted. So why were those highlighted and not like the ones across, right? Could have been highlighted anyway, but for some reason there was a pattern with those. All right, well, let's look a little bit closer. See if you could see it. If not, if you didn't get it, let's see if we could help you see it now. So first thing probably would check is, well, can we add them together? No, those can't be added. This has a 6, this has a 5. I don't see a 6 and a 5 there. We can't add them. So what happens if we multiply them? It kind of reminds me of us doing cross multiplying. That's what it kind of reminds me of. So what happens when I multiply 6x squared and 5? Oops, 5. What does that give us? Well, 5 times 6 is 30, so I have 30x squared. All right, so let me write that down. So if I multiply those, or let me do it on the bottom. So if I multiply those, 6x squared times 5 gives us 30x squared. Okay, so how does that help? Well, let's look at the other diagonal. If I look at those, and I take 2x and I multiply it times 15x, well, 15 times 2 is 30, and x times x is x squared. What? All right, so all of a sudden, let me highlight these. If we multiply those, they end up being the same number or same expression. Does that work for all 2x2 area models? Well, there's only one way to find out. Let's go back to our original ones, right? So this is the one we just looked at. So let's look at the others. So if I multiply 6 times 5, that gives me negative 30 with an xy. right? Negative 30 with an xy. And then if I multiply 15x times negative 2y, 15 times negative 2 again is negative 30 with an x and a y on it. Wow, that worked on that one. And let's see if it works on the last one. So this is 12 times negative 12. So if you're not sure about that one, those are bigger numbers. So 12 times 12 is negative, or negative 12 is negative 144 with an x squared. And if I multiply 16 times negative 9, what do you think it's going to be? I wouldn't even multiply that in my head. I would probably use a calculator. That comes out to negative 44, and there's an x and an x, which is x squared. So you'll notice again, if you multiply the diagonals, they end up equaling each other. So that's interesting to know. That's something that maybe we could use a little bit later when we start to figure out how to factor. All right. So that's all for this lesson. Let me know if you have any questions. Next lesson, we will be getting into the details of factoring.